So PrimeMatch was conceived as a visionary project, and it came to fruition nearly after 3 years of work and multiple challenges, and resulted to a product. And before I move on, I would like to also thank the extended team. So their collective effort at JP Morgan was actually instrumental for the transition of the product to production. And the team was very diverse. It had quants, like MPC experts, cybersecurity experts, like salespeople. Okay, so it was very diverse, salespeople and more. Okay, so just some broader motivation. So I believe that you have all heard about the first and the one-time application of MPC in Denmark, okay, back in 2008, which was a double auction for sugar beets. And since then, there were no actually other applications for many years of MPC. And then here you can check the MPC dashboard created by some folks from Berkeley. There they report adoptions of MPC in the industry. There are not so many applications, and most of them are on wallets. But in general, MPC is getting adopted more and more, which is more exciting. So here we try to identify like some real-world application for MPC in the finance world. And there was a lot of academic work on what is called privacy-preserving dark pools. I'm going to come to that at the end of the talk. It's basically continuous double auctions, but none of this works is deployed actually in production, okay? So then we went back to the beginning, rethinking about auctions, and tried to actually have a profitable product, and that's what PrimeMatch came about, okay? So this is the outline of the talk. I'm going to give you the motivation for PrimeMatch and what it is exactly, some intuition about the cryptographic tools what we're using behind it, and then I'm going to actually show you a demo too, okay? So what was the process before we deployed PrimeMatch? So the process was the following. So banks try to locate stock matches between buyers and sellers at discounted rates, okay? Avoiding some costly fees that you need to have if you go to the open public markets, okay? And what they do, so every day they send a list of their inventory to clients, okay? And the clients here are hedge funds. Here, this business has like around 60 clients, okay? So the clients see the list, so the list looks like that. So it's simple, it's like Apple, Microsoft, Google, okay, you name it. And then we have the side, long and short. So long, for this stock, you can think that long is for buy and short is for sell, okay? And then the volume, okay, how many shares you want to buy or sell, okay? This is how it looks. And this happens every day, and all the banks are doing this, okay? However, there are some issues with this approach. So first, clearly the bank reveals their own inventory, okay? And then the clients have raised some concerns. So what is the concern here is that, let's say I bought from a client yesterday a very large order, okay? So now my inventory is increased by this large order. So those clients complained, saying that now that your inventory today is increased by that much, maybe somebody can say that you bought it from us yesterday, okay? So these clients have asked to remove all the trading activity we do with them from the list, okay? So this results in a reduced inventory that we can send to the clients, okay? Apart from the fact that we are revealing our inventory. Okay, so, and also the other thing is that clients, of course, they don't want to send their inventory, okay? They don't want to reveal what they are willing to execute because this will reveal the strategy and all of that, okay? So the solution here is that we can have the clients also submit their inventory, but of course encrypted, okay? Or masked. So in this example, for instance, you can see, let's say the client submits their inventory encrypted, then we try to check it with the inventory of the bank. So here, for example, you can see there's a match here. So this client asked for 300, and we had only 200. So we can match this 200, okay? And what is being revealed here, we will only reveal the matched quantity, okay? So we'll reveal that we matched the 200, and we will never know that the client asked for 300, okay? So this is what is being revealed, okay? We will know nothing. If there's no match, we will not know anything. We will not know if it was Apple or anything, okay? And the main computation that we have to do here is computing the minimum, okay, between like the volumes of the client and the bank, okay? This is the most costly operation that we have to do in a cryptographic way here. Okay, so here is a summary of what I just said, that we have a bunch of clients that send their inventory encrypted to the bank, and then we try to match it. And we can even do something more exciting. So if we don't have the inventory that the client is asking, let's say for Apple, we have 0 volume. But 2 clients can be matched together. So we can also do client-to-client matching. Matching, that's how we call it, okay? And again, only the matching quantities are revealed. Okay, so in terms of cryptography, so we have actually the main cryptographic new thing that we do here is a secure comparison protocol and comparing this protocol to the previous works. So we managed to have a protocol which doesn't require any nonlinear operations, so meaning that the parties now can actually calculate that locally without interaction. Okay, and the other thing is that the round complexity of previous protocols was logarithmic in the number of bits that you're comparing, okay? So here, we only have 2 rounds, okay? You send the data to the server, and then you compute everything locally, and you get the answer, okay? And we also made those protocols maliciously secure in an efficient way, okay? So this is the cryptographic contribution. Like, we couldn't use some crypto tools from the south, okay? And now I'm gonna tell you, like, quickly, because we don't have a lot of time, about some challenges to put this product in production. So some generic feedback here is that when you try to sell something like that to the bank, they will ask, okay, show me another application that they use the MPC. And there was nothing, right? So we cannot show as an example, look, there's this application. There was nothing like that. That was kind of like a negative thing. But the positive thing is that the bank has already like long-standing clients that they're willing to try new things. So that was very positive. That indeed helped a lot for this application. Okay, and what steps we had to take? So first, we also had to sell the product internally in the company, okay? And then we moved to externally. So some steps that we had to do, first talk to the quantitative research team that they are doing this application that I showed you earlier, this inventory matching, and tell them like, are you interested in auctions and what type of auctions you will be interested? And then that's how we found this use case of the inventory matching, and we showed them the first demo, and then they got convinced. And then we went to the salespeople. So the next stage was to go to the clients and ask them, okay, will you use such a product if we build it? And moreover, not only like ask them this question, but also ask some technical implementation challenges, like how they would like the product to look like for them to use it, okay? So we went to almost 20 clients, and we got a lot of feedback. I mean, we were showing them demos. I mean, there was a lot of feedback. I mean, making and talking about feedback, it's a different like talk, okay? There was a lot of interesting feedback and surprising feedback, but that's another talk. But given the generic feedback, they decided actually to move on and deploy the product. Okay, so I'm gonna mention some highlights that the clients asked for the product to have to first be able to use it. Okay, so they asked that they don't want to communicate with any other client, okay? So here, what really could work was a star topology where you only talk to one server, which is the bank. And realistically, trying to have an MPC application where you try to make 60 clients talk together and creating a network of 60 nodes talking to each other, I mean, it's very realistic, okay? There was no chance to achieve something like that. And also the clients also want some anonymity, okay? So for instance, they didn't want to know that they're participating in the auction, okay? So they even didn't want to hide that it's them, okay? So we cannot make them talk with another client because they will see that they're participating. Okay, also they didn't want to install heavy tools, okay? So we decided to have a web-based application for that. Then, of course, the client computation, they wanted to be minimal. Also, like, they don't know at which auction they will come to participate. So there's no question about pre-processing here, which is like something very useful you can use in MPC. Okay, of course, they wanted malicious security and also a peer review of the solution, okay? That's like just a quick summary of what I can tell you in this short period of time. Okay, and also, of course, you want to participate in auctions fast, so you don't want them to run forever, okay? So about the cryptographic solution, I will not tell you a lot of details because there's not a lot of time. But essentially, we use secret sharing, okay? And we use what is called committed computation. So I'm going to tell you here the very high level how to get malicious security. So basically, we run the protocol that we do secure comparison 3 times, okay? Once we run it on the secret shared values, so meaning like one party secret share their input, think that A and B are the volumes that we want to compare. So they send one share to the other party. So party 1 sends another share to the other party, okay? And then we run the secure comparison protocol that I'm not telling you how it works, but remember, it uses only linear operations, so parties can compute locally. And then they send some secret state to the server who can actually reconstruct the answer, okay? So this is the semi-honest protocol, okay? So now, to check that the client ran the computation correctly, we are running also a second instance of what the second client is supposed to run on the committed share of the other party, okay? So for instance, this party sent A2 share to the second party, but also sends a commitment to A1, to the first share, okay? So in that way, we also run the committed computations, okay? Here we just have the commitments. And then the server can actually check, and we need also a third one, because the commitments, we don't have the randomness of the commitments, so you also need to run it on the randomness of the commitments for the server to be able to check that the computation was done correctly, okay? So this is super high level. If you have more questions, feel free to ask me, okay? So let me show you quickly the demo. So again, I'm gonna show you the client side, okay? And remember I told you it's a web-based application, which is hosted on these JP Morgan markets. So the client logs in there. And then they can actually go to Primat. So here, I recorded this in March. So you can see that there are auctions every 10 minutes. Okay, so we have the registration phase that they can come and submit orders. Then we wait for a bit, okay, for 5 minutes. And then we start the matching, okay? So then we click on the current auction. And this is what the client sees. So what happens here, I have a short video. So what happens here, the client has a file of its inventory, okay? Tries to find the file in its computer. And basically what happens, this file will be encrypted locally, okay, on the browser. And then it will reach encrypted to JP Morgan. So the file that we uploaded has like the name of the symbol, which is fake here for the purpose of the demo. And then the symbol type is like at what system we have this simple name. Okay, everything is displayed, the same thing is displayed here on the screen. Okay, so we have the simple type, the simple. So all of these columns, they are all to check that we're talking about the same symbol. Okay, it's different representation of the same symbol in different systems. Then we have the minimum quantity and the maximum quantity, so I didn't mention that. So the client submits 2 volumes. One is the minimum, that he cannot accept less than that to be matched, and the maximum is the maximum value. And then the client clicks register, okay? And then everything is registered, meaning that everything is sent to the server encrypted, okay? So then the matching starts, so let me play also this video. So when the matching starts, we first start to match the minimum quantities, and then we match the maximum quantities, okay? And if there are multiple clients, we actually process them one by one. So what I'm showing you here is this client to bank matching, what I'm showing here, okay? So at the end, we can see that, for instance, here, we have a full match, so the client asks maximum 90, we give them 90. And here, for instance, we have partial match. The client asked for 440, and we only gave them 300, okay? And to conclude, so we have this application of prime match and some future work. We're also trying to do what is called fair matching, meaning that we want to maximize the number of matches that we can have between clients. We don't want the client to come and get the full inventory at once. And then there are the dark pools. So the dark pools is exactly the same application, but there's also price involved. So you're trying to match both the volumes and the price. And the portfolio is that now you have a full list of the portfolio of the client, and you try to do multiple things with it, which is like pricing it or finding the most optimal strategy for the client, okay? So after this, the prime match, we believe it's the beginning of like using MPC in the banking sector, and we're also working on these other use cases. Thank you.